In 4.1, we are looking at detours and midpoints. This video will focus specifically on detours, and there's a separate video for midpoints. So detour proofs are a little more challenging, but there's no new axioms, no new definitions or theorems. It's just a new procedure. So this procedure is outlined in your textbook, and you can read through it there. What I'll do is talk you through it. So here we're given AB is congruent to AD and BC is congruent to DC, but we need to prove triangle ABE is congruent to triangle ADE. We can't do that with the current information. What we can do is call AC reflexive, and then we can say triangle ABC is congruent to triangle ADC. Then we could use corresponding parts, and then we could later say AE is congruent to itself. Then we would have ABE congruent to triangle ADE by side angle side. So let's go ahead and do that. So our first set of triangles is the larger pair. And I'm going to draw those separately, and you should. When you're drawing detour proofs or writing detour proofs, you are going to be assessed as to whether or not you're clear on which triangles you're proving. So we have AB is congruent to AD, and that's given. And I may as well, since I'm going to use it right away, note BC is congruent to CD, also given. Then AC is congruent to itself by the reflexive property. And now we have triangle ABC congruent to triangle ADC by side, side, side. First side is in line 1, second side also in line 1, and the third side is in line 2. Now I want to be sure that I'm marking my diagram on these. And notice that my markings now don't match the original diagram, and they should. So I'm going to go back and change that. You want the tick marks to be consistent. I can't mark AC on the original diagram because of point E. So I'll just mark it on the separate diagram, which is also part of the reason you draw the second diagram. Now, I am going to take these as corresponding parts, and I'm going to draw out a separate diagram for triangle ABE and triangle ADE. And I can use that AB is congruent to AD from up here. So we have the corresponding parts. Angle BAE is congruent to angle DAE. If we're given congruent triangles, then corresponding parts of congruent triangles are congruent, and those triangles are in line 3. Then we can say that AE is congruent to itself, again by the reflexive property. So now we have triangle AB congruent to triangle AD by side angle side from lines 1, 4, and 5. And I'm going to go back in my left margin here and note that for the first triangle. And make sure that I've marked my diagram completely. I think I'll use an X this time for that reflexive. Let's look at another example. Given WX is congruent to WZ, and I know I'm going to need to prove triangles, so I'm going to start drawing those out right away. And then XY is congruent to ZY. And I'm trying to mark my smaller diagram identical to the larger. And then WY is congruent to WY by the reflexive property. And I always want to make sure that I'm using the correct notation. So then that makes triangle WXY congruent to WZY by side, side, side. My first side is in line 1, my second side is in line 2, and my third side is in line 3. And I've marked my diagram as best I can. I can't really mark WY on the larger original diagram because of point A. But I can mark XYW congruent to ZYW, and that would be, if we have congruent triangles, then corresponding parts of congruent triangles are congruent. My triangles are in line 4. And I'm supposed to be trying to prove triangle XAY congruent to triangle ZAY, so I'm going to now draw those separately as well. And I know already that XY is congruent to YZ, and that's a side. And then I have the corresponding angles that are congruent. So now, if I could say AY is congruent to AY, I would have an additional side. So now I have side, angle, and I can mark that on here. Side by lines 2, 5, and 6. So here we are given MN is congruent to NS, and MP is congruent to PS. So that immediately leads me to draw out those segments, and they don't have to be to scale because we can number them or label them. But we should use the same tick marks on both diagrams. So we were given this information, which is a side and a side, and then PN is congruent to itself, which is another side, by the reflexive property. So then the two triangles are congruent by side, side, side. My first pair of congruent sides is in line 1. My second pair is also in line 1. And then my third pair is in line 2. So now I have corresponding parts. MPQ is congruent to SPQ. And I think I should draw those out separately as well. Hint, hint. And I know I went ahead and drew the whole triangle because I know that MP is congruent to SP. And now these are the corresponding parts. So then I could go ahead and say that PQ is congruent to itself by the reflexive property. So MP, that was here, that's going to be my side. There's my angle, and there's my other side. And then congruent triangles implies corresponding parts of congruent triangles are congruent, but this set of triangles is in line 6. So MQP is congruent to SQP. Some of the detour proofs can get very long. These will probably be the longest proofs that you'll write all year. So we start off in this proof, given circle O and WX is congruent to WY. So we're given circle O. We can draw OX and OY because any 2 points determine a segment. And then we can say that OX is congruent to OY because if we're given a circle, then all radii of that circle are congruent. And we needed lines 1 and 2 in order to say that. Now that's going to be the first side of our triangle. We were also given the WX and the WY, and I started marking those immediately. And then we have WO is congruent to itself by the reflexive property. So now we can say the triangle is congruent by side, side, side. 3, 4, 5. And I mean triangle WXO is congruent to WYO. So we need to say that WZ bisects segment XY, which means we will need XZ congruent to ZY. And that suggests we're going to need triangle OXZ congruent to OYZ. So I'm going to say that OZ is congruent to itself by the reflexive property. And then WOX is congruent to WOY by corresponding parts. So then we can see that WOX is supplementary to XOZ because if two angles form a straight angle, then they are supplementary angles. And the same on the other side. So now angle ZOX is congruent to angle ZOY because angles that are supplementary to congruent angles are congruent angles. And that comes from lines 8 and 9. And now, by side angle side, our first side is here. There's our angle, and there's our other side. We can say those two triangles are congruent. The lines 3, 8, and 7. So to improve organization, it actually would have been better to move this line 7 here. If I could have slid that in there, that would have improved the organization. So as long as I'm aware I'm going to lose one of the 18 points, so I'd get a 17 out of 18, still an A, but not an A+, for organization, the way it's written now. And then XZ is congruent to ZY. And these triangles are in line 11. And if a line, point, or segment divides a segment into two congruent segments, then it is a segment bisector. And I just want to go in and make sure that I've marked all of my corresponding parts and that I've noted everything. So let's try writing a proof rather than doing a fill-in. We're given triangle ABC is isosceles with base BC, and AD is perpendicular to BC. I need to prove triangle BEC is isosceles, which means I either need to prove BE is congruent to EC or this angle is congruent to that angle. Because remember in 3.6, we learned that an isosceles triangle has at least two congruent sides or two congruent angles. But I'm thinking if we're given ABC as isosceles, we can probably start with the two larger triangles. Because we would have AD as reflexive, the right angles, and then we'd also be able to say that those are congruent because it is an isosceles triangle with base BC. So I think I'm going to start by proving those two triangles congruent by hypotenuse leg, which means I need to begin with my right angle. So AD is perpendicular to BC is given, which means angle 1 and angle 2 are right angles. So there's my right angle. Now I need to say that the hypotenuses are congruent. So we are given triangle ABC isosceles with base BC. So that means that AB is congruent to AC, because if you're given an isosceles triangle, then you have at least two congruent sides or segments. So that's my hypotenuse. And now for my leg, I can say that AD is congruent to AD by the reflexive property. And I can't really mark it on the original diagram. I zoomed out a bit because I'm running out of room. So now we have triangle ABD congruent to triangle ACD by HL, and my right angles are in line 2, my hypotenuse is in line 4, and the leg is in line 5. Now that I have those congruent, I can say BD is congruent to DC, because if we have congruent triangles, then corresponding parts of congruent triangles are congruent. And what I'm looking at in here is, I used the circle already, maybe I'll use an X, saying that ED is congruent to itself by the reflexive property, And now I can say triangle DEB is congruent to triangle DEC by, oh, I never said the two right angles were congruent, so I'm going to have to go back and do that. Which means I have to move these two lines down. Squeeze in a line 8. Angle 1 is congruent to angle 2. Because if two angles are right angles, then they are congruent angles. And that comes from line 2. And then we have side angle side, lines 7, 8, and 9, which would then make BE, congruent to CE. And the triangle is in line 10. And then for a final line, triangle BEC is isosceles, because if we have congruent segments, then we have an isosceles triangle.
If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.